All right, so let's start. Our objective for today, I can factor polynomials. I can factor polynomials. Read it together. 1, 2, 3. I can factor polynomials. Tell your neighbor what concept we're revisiting again. Yay, our favorite. Kind of like those movies that you're walking down the street and all of a sudden you turn the corner and ton, ton, ton. Polynomial right there. No? Okay, never mind. All right. So yes, we're coming back to polynomials because before we go into chapter 9, which is dealing with polynomials and equations, we need to make sure we finish polynomials by doing multiplication and factoring. So today we're going to be doing factoring, okay? So with that said, you don't have to copy this. You already have this. What are polynomials? We said there are monomials or the sum and difference of monomials. So 2 is a monomial, x squared is a monomial. This is a binomial because it's 2 monomials, a sum. And this is 3 monomials. It's the sum and difference. These are non-examples because these are equations. Right now we're just looking at expressions. So therefore, expressions only, there's terms. Copy these steps down, please. Step 1, identify the greatest common factor for each term or every term. Step 1, identify the greatest common factor for every term. Step 1, identify the greatest common factor of every term. Step 1, identify the greatest common factor of every term. Step 1, identify the greatest common factor of every term. Step 1, identify the greatest common factor of every term. Step 2, rewrite the polynomial using the GCF and remaining expression. And that's what we call as factors because we're going to be multiplying. Rewrite the polynomial using GCF and the remaining expression. Step 3, check your answer. Check your answer. So here we go. Step 1, I want you to circle identify and underline GCF. So step 1, memorize that step because we're going to be using it a lot. So you neighbor what I just said. So identify GCF. Step 2, rewrite using GCF and remaining expression. Rewrite using GCF and remaining expression. And step 3, check. Fairly simple steps. Step 1, we need to identify the GCF. Step 2, we rewrite the expression using the GCF and the remaining expression. And step 3, check. Step 1, identify GCF. Step 2, rewrite using the GCF and remaining expression. Step 3, check. Step 1, identify GCF. Step 2, rewrite using GCF and remaining expression. Step 3, check. Tell your neighbor the steps, please. All right, let's see. Copy this term, factoring. If it fits on your left side of your Cornell notes, fit it in there. If it doesn't, then write underneath your steps. Factoring, the process of finding factors of a number. Factoring, the process of finding factors of a number. Factoring, the process of finding factors of a number. I'm not asking you to copy factors because we already covered that, right? Factors are 2 or more numbers that multiply or anything that gives us a product that are multiplying, those are factors. But factoring is the process of finding the factors of a number. Underneath that, I want you to write this example. Example. Check this out. If I wanted to ask you for the factors of number 6, okay? Think about one factor. What would be the first factor? Let me see. All right. Okay. Some of us right away we thought 2. Is that correct? 2 is a factor because if it's multiplied times another number, it's going to give us 6. However, if I start with a number 2 and I use 6, what do I need to do to 6 with that 2 to get the other factor? I divide. So 2 fits in there how many times? 3. So in order to get the other factor, 2 times 3 gives us 6. These are factors because they're multiplying. What is this process that I just did? What is this process called? Factoring. That we used to call it what? Dividing. Factoring is the same thing as dividing. Everybody got it? because I'm going to be using the words factors and factoring, and I don't want you guys to get confused with one to the other. These two are factors because they're doing what? Multiplying. And this process to get these numbers is called what? Factoring, which is what? Dividing. Okay? Yes? All right, let me clarify. If I give you two numbers such as 2 and 3, these two numbers are just numbers. As soon as we get those two numbers and we multiply them, they are called factors because they give us a product. Are we there? All right, with that said, copy example number 1, please. Example 1. So copy the black text. It says, factor each polynomial and check your answer. Factor each polynomial, check your answer. Write down 2x squared minus 4. 2x squared minus 4. All right? Here we go. Pens down, eyes up here. I'm going to go over the first example. I just need you guys to pay attention. Then I'm going to give you another one for you to do by yourself. Here it goes. So let me go through the process. Step 1, identify the GCF of each term. So what are they talking about with terms? The parts of the polynomial. So here we have term number 1, term number 2. Okay, and I'm trying to refresh your memory because we saw this some time back, right? So let's see. We got two terms, and I'm thinking, what is my greatest common factor? I'm going to start with the numbers. What number divides into 2 that divides into 4? That is the greatest number that you can think of. And we think of number 2. Is that correct? Because both of these can also be divided by 1, can't they? Yeah, but the greatest number is 2. All right. The next question is there a variable that divides into each term? Does this have a variable? No, so therefore we cannot divide this term by a variable. This one only, but it has to be present in both. So in that case, I just go with a number, and I open up a parentheses. And then I start my division. What is 2 divided by 2? 1, and I bring the x squared over. Now let me show you what I just did. 2x squared divided by 2. Remember these? Yeah? So therefore, to simplify this one, what is 2 over 2? 1, and what do we have left over? X squared. That's how we get that. Let me do the second part. This one. Negative 4 divided by 2. What is that? Negative 2. To check it, all we have to do is, what's the inverse of division? Multiplication, which is distributive property. So what is 2 times 1x squared? 2x squared. What is 2 times negative 2? Negative 4. Copy that, please. Bless you. Okay, now check this out. The reason I wrote this so that you see what the process is in factoring. I'm not going to be writing this out. I'm just showing you how do we get this simplification here after we factor out a 2. Okay, that's why I wrote them, so you can see the process that goes into it. Everybody with me? Okay, copy this next example, example 1b. You don't have to copy the black text. Just copy the polynomial. Here it goes. Copy that one, please. Example 1b, copy negative 14x minus 12x squared. All right, let's do this one together. Let's see. Here's one term. Here's 2 terms. What number divides into the first that divides into the second? 2. Okay. However, who notices that both of these terms have a negative as a coefficient? Therefore, we can factor a negative also. Are we there? Okay. Now let's look at each term. Do we have an x in each term? Yes, so we can factor out an x. Do we have an x squared in each term? No, only on the second. So I'm done up to right there. So I open parentheses. And let's see. What is negative 14 divided by negative 2? 7. What is x divided by x? What is x divided by x? 1. What is 1 times 7? 7. So that's all we write right there. And once again, here it goes again. I'm going to write it out so you can see it. Negative 14 divided by negative 2. We have x and x. Let me simplify this one. X over x is 1. What is 1 times negative 14 over 2? Negative 14 over negative 2. Everybody see that? Therefore, what is negative 14 divided by negative 2? Positive 7. Do we have it now? Okay, with that same thought, let's do the second part. What is negative 12 divided by negative 2? Positive 6. What is x squared divided by x? X. And to check, let's distribute. Let's see if it works. Negative 2x times 7, that's negative 14x, yes. Negative 2x times 6x, that's negative 12x squared. Okay? All right, so check this out. What are they asking us to do? To factor. What does that mean? That at the end we're going to get two amounts that are doing what operation? Multiplication. That's why we need to indicate it somehow. That's why this is in a parentheses indicating what? Multiplication. Everybody got it so far? Okay, example 1C. Copy this down. Once again, you don't need to copy the black text. Just copy the polynomial. 1C. See if you can do that one by yourself. All right, let's see what we got. Let's see. 8 could be divided by 2, 4 can be divided by 2, and 16 can be divided by 2. However, the greatest factor that they all have in common is what number? 4. Okay. Do all three terms have a negative as a coefficient? No, therefore I don't write a negative. Okay. Do all three terms have a variable x? Yes, there it is. Do all three terms have a x squared? No. So therefore I'm done up to right there. I get my parentheses, and it's our factoring. 8 divided by 4, 2. X cubed divided by x, x squared. Negative 4 divided by 4, negative 1. X squared divided by x is x. Negative 16 divided by 4, negative 4. X divided by x, 1. What is 1 times 4? 4. So it's already there. If we distribute to check, let's see. 4x times 2x squared is 8x cubed. That is correct. 4x times negative 1x is negative 4x squared. And 4x times negative 4 is 16x. Okay, hands if you got that by yourself. Okay, let's do another one. Copy this one down. Example 1C. 1D, my bad, 1D. See if you get that one by yourself. All right. Let's see. What number divides into the first, second, and third term? 1. Do all three have a variable? No, so we're done. So then we just write 1 times 3x cubed plus 2x squared minus 10. And we're done. To check it, what do we do? Distribute. 1 times all this is all that. Okay? Okay, next, copy this one. 1E. Do that one by yourself, and then I'll get somebody to help me out and work through this one. All right, so, okay. All right, factor. We got 8x to the 4th plus 4x cubed minus 2x squared. So a number that divides each of these numbers is 1, is that correct? But also 2. Okay, so I'm going to write 2 right here. All right. Do we have an x in each term? Yes. Do we have an x squared in each term? Yes, we do. Here, let me show you. This is x to the 4th. This is x times x times x times x. This is x to the 3rd. X times x times x. This one is x squared. Okay. Do we have 1x? Yes. 1, 1, and 1. There it is. Do we have two x's? Yes. X times x, x times x, and what is x times x? X squared. So if you don't see it, remember, when in doubt, factor out so you can see it in front of you. If you don't see it, you need to factor it out, okay? So here we go. So open your paren. 8 divided by 2, that's 4. X to the 4th divided by x squared is x squared. Plus 4 divided by 2 is 2. X cubed divided by x squared is x. Negative 2 divided by 2 is negative 1. X squared divided by x squared is 1, which 1 times 1 is 1. So to check it, let's double check. 2x squared times 4x squared, that's 8x to the 4th. 2x squared times 2x, that's 4x to the cube. And 2x squared times negative 1 is negative 2x squared. Hands if you got that by yourself. Okay, let's do another one. Here we go. Copy this one. Example 1D. 1D. Oh, 1F. My bad. 1F. All right, let's do this. Let's see. What is my number that divides into both terms? 1. Do both of them have a negative? So it's a negative 1. Okay. Do both have a y? Yes. Do both have at least a y squared? Yes. So therefore, we open up a parentheses and start our factoring. Let's see. Negative 18 divided by negative 1 is positive 18. Y cubed divided by y squared is y. Negative 7 divided by negative 1 is positive 7. Y squared divided by y squared is 1, and 1 times 7 is 7. And to check it, of course, we know that we need to distribute, and we should get this. And if you got that by yourself. Okay? All right, so let's start having some fun. Here goes, let's increase the steps. Here we go. Copy this down, please. Not the whole thing. Copy what I underlined. The area of a court is 9x squared plus 6x. And then I want you to underline the question or write down, find the dimensions of the court. M squared, that's the meter squared, and I'll address that. I just didn't want you to get you confused thinking that that's another variable. So copy what I underlined. All right, it says the area of a court for the game of squash is 9x squared plus 6x meters squared. That's why I didn't want you to write this down as part of the area of the court. But at the end, it's in meters squared. They say, find the dimensions of the court. How do we find it? By factoring. So if the area is 9x squared plus 6x, do the next step and find me the dimensions of that court. Go. All right, let's see. What's our GCF? 3x. And what's left? 3x plus 2. So our sentence will be the dimensions of the court are 3x meters by 3x plus 2 meters. 10 cubed. Okay. All right. So, any questions with these word problems Okay, I'm going to give you another word problem. I want you to do answer the question, please. You don't have to copy the entire text. Just copy key information, all right? Here we go. Next one, example 2A. It says, the area of a solar panel on another calculator, okay, let's say on the calculator, is 2x squared plus 4x, and that is given in centimeters squared. Factor this polynomial to find the possible expressions to find the dimensions of the solar panel. So write key information that you might need from that problem, but of course you're going to write the polynomial and finding the dimensions. Go. Okay, let's see. Hands if you got 2x times, 2x times x plus 2. And your sentence should have been the dimensions of the solar panel are 2x centimeters by x plus 2 centimeters. Okay. So we got these, yes? All right, let's move on. Example 3. Copy this down, please. A and B. Copy these two. Example A and B. 3A and B. They're a little bit different. That's why just copy them. I'm going to guide you through A, and then you're going to do B by yourself. So copy those, please. A is 5 times x plus 2 plus 3x times x plus 2. For B is negative 2b times b squared plus 1 plus b squared plus 1. All right, pens down, eyes up here. You'll finish copying right now when I give you a chance to do the second one. Everybody look up, please. All right. So, look at the first example. This one has 2 terms. It might look like a lot, but there are only 2 terms. Each term begins and ends with a plus or a minus. So check this out. Here's the first term. It starts and it ends right here. The second term is from here to here. Do you guys see it? All right, so now let's look at it. What is the same? Everybody look up, please. Here and here. Don't say it out loud. Just think about it. What does this term have that this term has? Okay. Okay. Did everybody see that it's the x plus 2? So I write, that's my greatest common factor. I'm going to write it out. X plus 2. So therefore, I got the x plus 2 factored out of each term. Everybody look up. What's left of the first term if I factored out the x plus 2? 5. And what is left on the second term? Plus 3x. And this is another factor. Copy that, please. Yeah, do letter B by yourself. Nice and neat. All right, let's see. What does this first term have that this second term has? B squared plus 1. That's my GCF, and that's my first factor. So what's left of my first term? Negative 2b. What is left of my second term? Plus 1. Because there's a 1 right here, coefficient. So that's my second factor, and we're done. Okay? Now, to check this, how would we check it? Bam. Remember when we used to multiply binomials? So you would circle this, distribute, and then you circle this and distribute, right? Okay. Any questions? No? You sure? No? All right. Okay, copy. Yes? Okay, copy this next one. Do those by yourself. All right. Look at this one. So for this one, you saw that this term and this term have in common what? The s plus 6, x plus 6. What's left over for the first term? 4s. What's left over for the second? Minus 5, and that's my second factor. I'm done. Look at this one. What's the same on the first and second term? 2x plus 3. And what's left over here? 7x plus 1. Hands if you got those two by yourself. Okay? All right, copy this down. This is one of the last examples that you're going to see. Example 4a. 4a. All right, check this out. I'm going to do this one, so pay attention with the steps. Here it goes. Pens down, eyes up here. It says factor by grouping, by grouping, by grouping. All right, so check this out. Everybody look up, please. I'm going to group the first two terms. Notice that there's 4 terms. 1, 2, 3, 4 terms. You guys see that? I'm going to group the first two. This one and this one. This one and this one. Are we there so far? Now let's focus first on the first two. What's the GCF of these two? 2h squared. Oh, cubed. My bad. Yeah. I was testing you guys. So 2h cubed. And what's left over if we divide? We're left with 3h minus 2. Is that correct? All right. So let's look at this one. The plus, and what's the GCF for these two? 4. And what is 12h divided by 4? 3h minus 2. Now, does this look familiar? Yes. What do both terms have in common? 3h minus 2. And what do we have left? 2h cubed plus 4. Boom. Homework. Page, what page is it? What is it? 491. Numbers 1 through 43 odd. And 54. All right, guys, have a good one. Enjoy your homework. Turn in your homework on your way out. Have a good one. See you guys tomorrow. Tutoring today. Enjoy your homework.